Well, hello, everybody, and welcome. Thank you so much for joining us for this special Actual Tech Media webinar event, Next Generation AI Infrastructure, presented in partnership with NetApp and NVIDIA. I'm James Green. I'm going to be your moderator for this event. And before we get started, I have just a few housekeeping things I want to go over with you. We got a lot to get through, so I'm going to make this really quick. First of all, there's a Q&A panel where you can submit your questions to the group, and we're going to be taking some of those questions at the end. I want to make sure that you have an opportunity to get your questions answered. So make sure that as we go, if you have questions, you pop those into the questions panel. We're going to respond to those. And by the way, we have a $50 Amazon gift card for the very best question. We will go over every one of those questions after the event, pick the very best one, and we'll reach out to you and deliver that. So some incentive to put some extra thought into your questions. So put those in the Q&A panel. As well, in your event console, there is a handout section where you can get some supporting material and dive further into this topic as the conversation here progresses. So check the handouts section for those. And finally, at the very end of the event, we're giving away a $300 Amazon gift card to one lucky attendee. So make sure you stick around at the end where we'll announce that. We'll also reach out to you after the event is over if you're the winner. And to be eligible to win that prize, I was just trying to flip to the bottom of this slide here, you must meet the Actual Tech Media prize policy, of course. If you go to actualtechmedia.com, scroll to the very bottom of the page, in the footer there, you'll find a link to the prize policy. So that goes for both the best question gift card and the $300 Amazon gift card. So without further ado, let's get into the meat of the conversation. I want to introduce you to your guests today, presenters from NVIDIA and NetApp. First, we're going to hear from Michael from NVIDIA. And then when Michael's done, he's going to kick it over to Ray from NetApp. So Michael, why don't you start by introducing yourself to the audience, and let's get going.
Sure, thanks, James. Let me just share my screen right here. All right. Yeah, my name is Michael Ballant, and I work at NVIDIA. I'm a product architect. I actually span a number of roles. Part of what I do is more in product management, and I focus largely on building the next generation of AI infrastructure. So that's what we'll talk about today. That includes everything from how do we set up clusters of really powerful systems to what is the software that we deploy to bring all of those systems together as a cluster to orchestrate them, and then how do we build levels of software on top, basically to help data scientists to train models, whether they're large or they're small. So this is just to start things off. This is the era that we're living in, where we see this explosion in terms of model complexity, and specifically for deep learning models. The effort that's required, the amount of compute that's required in order to train some of these most demanding models is growing at an exponential rate. So this graph actually is logarithmic. We're showing petaflop days on the y-axis, and it's growing in factors of 10. And since around 2012, 2013 to modern day 2020, 2021 with GPT-3 and some of the very popular large models that you might have heard of for NLP, we've seen over 1 million times increase in the required compute to train these very demanding models. So a lot of what we do at NVIDIA is we investigate how can we continue to satiate this demand to train these increasingly complex models, and really it all starts with the GPU. A lot of what we think through is how can we very efficiently offload performance onto the training onto the GPU. Essentially, so that we are continuing to march towards a better supercomputing structure that leverages the GPU. So we go, instead of single-threaded type applications, we're parallelizing our efforts. And this graph really shows that part of Moore's law is slowing And this is why we have such an emphasis on offloading a lot of our applications and our training specifically onto the GPU. And it's not just through the hardware itself that we're able to see an increase in performance, but a lot of what we do is increase the efficiency of how we're doing our training through our software. That's leading to a continued exponential increase in terms of what we can train. The fundamental unit, therefore, is the GPU, and we, as I mentioned, we offload as much as we can, to the GPU, especially the very intensive functions. Whatever we can parallelize, we do. For something like deep learning, where you're using neural nets, that's quite easy to do. And even for other areas which we thought were difficult to parallelize, there's increasingly more evidence, more and more libraries that we're building on top of CUDA, where we're adding additional functions that can parallelize a lot of additional workloads. So, again, much of what we concentrate on is actually in the software, and how can we increasingly offload workloads to the GPU as that core component. And why does this matter? I think it matters not just in terms of training these very, very large models on large amounts of compute. So something like GPT-3 would be a model that would take on the order of several weeks, even if you have an extremely powerful supercomputer to train, and that's just a single model that you'd be training. But it's also important if you are training smaller models, if you're doing more traditional machine learning or any sort of data analytics. Really, why this matters is we fundamentally like to accelerate the number of iterations that a data scientist can go through, so that they're more productive. So on this chart, we're really showing the typical day in the life of a data scientist, and how much they have to go through to get the data prep just right, so that they can eventually get their work done. And a lot of what we focus on is again shortening that cycle. So if you have more performant compute, it doesn't just lead to training very large models. It also shortens the iteration cycles that it takes to get to being productive, and increases the number of experiments that a data scientist could run, and therefore also increases the accuracy or efficacy of a particular model that's been developed. So if the core component to what we do is the GPU, maybe the atomic manifestation of that would be a system like the NVIDIA DGX A100. That's really our all-purpose system that's specifically geared towards being plugged into a supercomputing type of infrastructure. And it can do everything from training to inference to more traditional ML. But what we focus on in terms of developing it is, can we build it for the most extreme workloads? Can we build it for that extreme use case of training a GPT-3 type model? And then, once we've developed that type of a system, it's very easy to repurpose it for all sorts of different types of workloads. So it's the world's first 5 petaflops AI system, and we're continually breaking new ground in terms of what we develop with the DGX line. I had the good fortune of joining NVIDIA when we released our first DGX-1 system. And so it's been an epic journey to see like every iteration of the DGX line, from DGX-1, DGX-2, DGX A100, building this universal building block that we plug into the data center, and really use as our core component to building something like a DGX pod or super pod type system that incorporates 20 to 140 nodes of DGX A100 systems. And this is also part of our relationship, and why we're so keen on working with NetApp is because NetApp is very in tune with what we do in terms of the DGX A100. Part of what we do with ONTAP AI is, leverage that DGX A100 unit, with storage from NetApp and provide a system that really is very versatile. It's very agile. It's not something that is, it's something that can adapt to different workloads. And so, whether you're, one day using, an overall system for analytics versus training, and then that switches to, in the reverse, in the opposite, the next day where we have more training or more inference than analytics. This is a highly adaptive system and makes use of that DGX A100 as a core component of it. And ultimately, what's valuable is not just using that DGX A100 system, but also, the fact that you have a reference architecture and a way forward in terms of, really building out a data center, at least from the hardware bit of things, which really shortens the time to getting productive, right? So instead of having to architect the system, the overall data center from scratch, there's a lot of effort that's been put into this best practice effort between NVIDIA and NetApp in terms of what does an ideal deployment look like. So at the end of the day, TCO is saved. You're able to get to production a lot faster. And really more, maybe perhaps more of the same thing, but this also shortens the development cycle, right? Because you're instead of wasting a lot of time trying to get up and running, you can get up and running in about a week. So let's go through a little bit of A, B's, and C's of building out a cluster. What we think about at NVIDIA, and what do we think about internally? What do we advise a lot of our customers to do when they're thinking about building out AI infrastructure? And the basic premise is really that you want to think about using these types of very high-powered systems like DGX as a cluster. You don't want to use them as dedicated systems. There's lots of folks that use them that way, but it's really not the most efficient usage. Even if you have users that are leveraging like an Excel spreadsheet where they sign up for the resources, that's still not very optimal, and we see that quite often. This is not optimal because there's a lot of coordination that's required. Ultimately, resources go unused. And at the end of the day, it's not scalable as a practice, and it's difficult to maintain. When we move over to actually deploying a cluster, this is a much better method because if we have a set of resources where we have an API to access those resources and deploy workloads on them, then that doesn't require user coordination. We can implement rules where there are quotas and certain users have access to a certain amount of cluster resources at a time, and perhaps overnight or during periods like over the summer where a lot of folks go on vacation. Perhaps you can use more of the cluster than you had gotten assigned to. Also, it's a highly scalable solution. It's easy to just plug in additional systems if you've architected the cluster right, so you can expand as there's more demand for the cluster, and it's easier to maintain the systems by taking some of the systems down and letting users use another portion of the cluster. So in terms of building out a cluster, also it's important to mention, to note where the cluster can actually be leveraged. It's not just, traditionally, I think we think of, a data center where we have many users accessing many nodes in the cluster, and that would be right. And in this sense, when we talk about leveraging DGX, typically that's the kind of case that we're talking about. But I just want to point out that there's lots of other paradigms for this, even just for a single system, especially when we're talking about a DGX A100 or perhaps like a DGX station where you have that single system. It's such a powerful system that oftentimes we see value in terms of encapsulating cluster software or an orchestration engine or scheduling around just that single system. So we allow lots of users to access that single node. Also, in this new era of the hybrid cloud, I think the third model of actually deploying a cluster has been popularized, which is really connecting on-prem systems with cloud resources and moving workloads from one set to another, especially if you have, it's especially valuable if you have a set of on-prem resources that can serve as your base. And then as you get more demand, should you need it, you can burst certain workloads to the cloud. We see also, higher prevalence of edge and IoT type of clusters where you might have training that's conducted on, at one site, and then you might be deploying your models at the edge to another site. So you want to incorporate everything and encapsulate everything, all these resources into a cluster, or at least several different clusters. And finally, in the case with production inference, perhaps this example is a little bit extreme, but you can think of having multiple systems that are just a farm that are scaling up and down inference workloads as a different cluster. So in terms of I mentioned cluster level software. You might have had questions around what are we thinking about when we talk about like a cluster API. Really, I think another fundamental component in this is what are you using to schedule your workloads? Right now, what we use at NVIDIA are two different pieces of software. We leverage Kubernetes and we leverage Slurm, and they both have their pluses and minuses. They're both used, ostensibly to deploy AI workloads. Kubernetes both can be used for training workloads, but Kubernetes really provides a very basic scheduling features. It does allow you to formulate that kind of cluster where you share nodes. You can schedule jobs on a GPU. You can even deploy. You can even do multi-node, conduct multi-node jobs with a little bit of tweaking. The plus is really that containers are our first-class citizen in Kubernetes. We have a lot of services that are built off of Kubernetes that you can deploy on top of it. There's a whole very vibrant ecosystem that's building solutions on top of Kubernetes, which we'll get into a little bit later. For Slurm, this is really what we think of as like an old school, job scheduler, and we use it in-house a lot at NVIDIA. It's our go-to solution for AI training jobs, and it gives you very advanced scheduling features, things like job dependencies, having more complex workflows where you might have like a graph of different dependencies. You can do that very easily. You can assign quotas to users. There's a concept of having multiple different types of queues. And there's much more just intelligent scheduling that goes on, better topology, hardware topology, awareness. All of these things can get very, very technical. But I think the important takeaway is really that for Slurm, this is really a power tool for doing very advanced AI training, with a cluster of power users. And when we think about building out our architecture, we're talking about AI infrastructure. It's important to consider, where does the software sit? There's more than just these GPU systems, the DGX A100 nodes that we're talking about. Of course, so in the extreme left column, on top of a system like that, like a DGX A100, we'd obviously have an OS that's geared towards that system. Certain systems configurations that pertain to getting the most out of those GPUs, and the NICs and network infrastructure that connects those systems to others. Our drivers and software on top. But you can think of running either Slurm or Kubernetes on top of these systems, at least the daemons that control whether a job is being scheduled or not on those systems. The other nodes that are involved in a cluster like this for Slurm, there's typically a login node where users can log into and schedule their work from. And then for Kubernetes, there are management nodes that need to run additional Kubernetes services and need to scale in their own right. So it's something that needs to be considered when you're building out this cluster. It's not just a farm of like a lot of different DGX systems. And in addition to this, it's, there's a lot that goes into deploying all of the software that goes into building up just to this, scheduler or orchestration layer. There's a lot that goes into, after we've racked and stacked the systems in the cluster, there's a lot of software that needs to be deployed. We need to deploy the latest version of the operating system in all systems. We need to deploy drivers, firmware, critical software, configure data access, deploy monitoring services, configure routing. There's so much that goes into deploying a system like this that it can be a little overwhelming if you're starting it from scratch. And so, that's why a lot of what we've done is take our learnings and open source a lot of what we do internally at NVIDIA in a repository we call DeepOps. We have our best practices encapsulated in that open source library and Ansible scripts that help with the deployment from 0 to getting something like Kubernetes or Slurm up and running, and examples of how to deploy additional services on top. This is really, this is not a product or anything like that. This is just, these are, whenever we make a best effort to encapsulate like some of our best practices in terms of bootstrapping an overall cluster like this. We'll get in a little bit later into products that we've actually formulated around this notion of DeepOps. But let me circle back to perhaps why we're doing all of this, right? So now we have a cluster, we have orchestration and job scheduling software on the cluster, but it's really not enough to stop here. And the primary factor for why is that during a lot of our research, we found that something like 87% of AI projects are never making it to production. And this is primarily because there are a lot of steps to training a model, testing it, and even before training a model, getting the right kind of data, massaging that data, cleansing it, making it, forming it into some sort of kosher kind of encapsulation that can be used for training, and eventually getting around to finally having a model. And then there's another can of worms of how do you actually deploy that model, and how do you monitor it in production? How do you detect that it's performing well, and how do you re-trigger training runs if it's deviating, if it's not performing well, and data has changed over time. So there's so much that goes into this, overall, operations of, maintaining building a model and maintaining it, that it's a very cumbersome effort, right? So, and what we've talked about here is ultimately that, that training phase and building a model, or experimenting with it at least, is just one step. It's there's so many other things that need to go into building a model and testing it and deploying it, that it often takes a large team of developers to accomplish this type of effort. It's also a very complex effort, one that involves lots of different types of people, different stakeholders, using different tools, using different types of approaches with different data sets, all trying to get their work done on a common set of infrastructure, or maybe even not a common set, but just lots of different infrastructure that might be spread out. So a lot of what we focus on in terms of building out a cluster is not just building that layer where you can just get your jobs executed, but there's a layer on top that increasingly is being called MLAPs, which we also focus on how to provide that additional layer so that we help the full development life cycle for data scientists. And it's important to focus on that because otherwise data scientists increasingly are doing that MLAPs work themselves, whether it is configuring portions of the cluster, so building up to that layer where you can actually have job scheduling and orchestration, or building little tools that automate part of the training procedure or the pipelines that they're building. Even if they're using open source tools, there's a lot of work that is often done by data scientists to just deploy those tools. So tools like Kubeflow actually seem very easy to leverage, but when using those solutions on a on-prem cluster, they become a real burden to deploy and manage and maintain over time, almost a job in itself. So providing this overall infrastructure is really important, not just from that hardware angle, but from a software angle, and really making it easier for data scientists to just come in and do their work. And so, what is that work? A lot of some of the common AI workflow use cases that we see are primarily these three different types. So, far and away, the most common is having an interactive session. And this is where a data scientist might want to request certain resources in the cluster. So let's say like 2 GPUs, they'd like a Jupyter notebook, and we'd like software that essentially goes in the cluster, uses the orchestration engine or job scheduling system, and requests those resources, and then presents the user with an interactive Python notebook that they can use in this interactive way. This can really be used for any sort of workload. Primarily, it's just experimentation. And then when the user is graduating to perhaps doing like hyperparameter optimization or building a more sophisticated type of flow, they might want to leverage a pipeline type workflow where the concept is similar. We're using an orchestrator or job scheduler to execute, in this time, a series of tasks where we're requesting system resources either in a sequential way, or we are executing certain things in parallel on the cluster. But at the end of the day, we're making good use of the cluster and writing our results to disk. Think of this as a way to instead of doing perhaps just an initial exploration or discovery, this is when we are really doing like lots of experimentation or building a more sophisticated ML workflow. And finally, we have deployment, where we want to serve, serve like a model. In this case, we can think of using the cluster as finding the right resources to deploy the model to. We're interested in meeting demand for using that model in production. So, if we need to scale that demand up, we can using the cluster resources. And if any of the apps or models that are deployed in production go down, we can automatically spawn a new service to take its place. So pulling all of this together, when we're building out AI infrastructure, it's important to start with that data center hardware, but ultimately we need a lot more software to build up the stack. Orthogonal to everything that we do is cluster management, and really building up this stack that I'm referring to. A base component of the software stack is the orchestration engine or scheduler that you use. Really on top of that is an AI platform or MLOps layer, which is what I was explaining a little bit earlier, that you also want to build on top of that stack. And then ultimately you want to consume containers, apps, and models at the top layer of the stack. So if you can provide this type of stack to your data scientists and your researchers, they're going to be a lot happier. They're not going to have to build the stack themselves, and they can ultimately get back to doing data science. And this is where, I mentioned, talking about products, we've put a lot of effort at NVIDIA in terms of building our own in-house solutions, and of which Base Command is one. I mentioned that we have some open source solutions through DeepOps, but really this doesn't get you through to ultimately a full stack type of solution. And so what we have in Base Command, and specifically in Base Command platform, is a managed deployment where we take care of all of the cluster level software, and then we provide a really nice GUI layer that data scientists can use their browser to point their browser at Base Command platform and really get started very quickly in terms of using notebooks, scheduling their workloads, even doing multi-node jobs on a cluster. There's lots of features in terms of job monitoring and telemetry that make using these really powerful resources just much easier. And as part of this, of course, this is also our engagement with NetApp. We use NetApp storage for everything that we do with our Base Command platform, and that serves as a really critical base to what we do, especially when it comes to a lot of the intense workloads that we run for deep learning, because if we don't have good storage, oftentimes the bottleneck can be the storage that you're using to pull your data off of. So, and thank you for your time. I'm going to turn it over to Ray, and Ray is going to walk you through a little bit more about the NetApp side of things and our engagement.
Thank you, Michael. Really appreciate the insight there and the deep dive. We're going to jump right into sharing out some of these business benefits about our partnership. Michael talked a lot about the what is it and the why you should care. I'm going to tell you now how we actually accomplish that. So as I mentioned, my name is Ray White. I'm the artificial intelligence leader for the Americas for NetApp. And if you don't know who NetApp is, I'm going to tell you all about it. But I want you to know that artificial intelligence today is what's making us smarter as humans. A lot of people say, is it going to outsource human technology? Is it going to slow us down? Is it going to replace it? And fundamentally, if you just think about radiology imaging detection, it's really one of my favorite stories to tell, because cancer has plagued my family and it's near and dear to my heart. So I really feel that the solutions that we're building together is really helping the world. And an average radiologist can detect about 30,000, screens a year, and probably has about a 90% ratio according to recent statistics that we saw. Now, using AI software, what if you could increase that ratio to 95%? What if you could use an algorithm and detect a cancer cell 5 years before a human eye can? So, artificial intelligence is not just about saving money, but also about saving life and doing things differently. And so I mentioned NetApp and NVIDIA. And so we love our friends at NVIDIA. There's such a powerful leadership there. The nearest competitor is easily 10 years behind what NVIDIA is doing from a software perspective, as we heard about from Michael. Very impressive. And the work that NetApp has done, NetApp is a cloud and data management storage platform company, period, end of story. And what we've done working with NVIDIA is we've created solutions that are designed for artificial intelligence, not that they technologically support it. I'm not saying, hey, follow the manufacturer's best practices and reads a bunch of guides. That's not what I'm saying. I'm saying we are building solutions that are designed for speed, built for artificial intelligence. And you're going to hear about two unique, exclusive NVIDIA and NetApp offerings that you can only get by these two companies, that NVIDIA does with no one else. We already heard about Base Command, and we'll go into our other solution as well. This is a recent output from our two CEOs getting together for our global sales kickoffs and our collaboration events for our partners. So the work that we are doing is deep and intrinsic. You may have heard of NetApp, but if you haven't, NetApp today runs the most prevalent deployed storage operating system and data management platform in the world. #1 in market share according to IDC. Again, many storage and data management companies have multiple operating systems and data management platforms. NetApp's Data On Tap, again, is the most prevalent deployed in the world. An over $6 billion company, 38,000 customers. NetApp's been around since 1992. And so we are not a new company, but we are absolutely the leader in this space. And with NetApp, it's really nice. You could run file, block, or object all in the same solution. You could run edge, core, or cloud all in the same solution. You could run my data management platform in a major leading hyperscale provider like an AWS, Google Cloud, or Microsoft Azure. It does not matter. And you can see why the integration story between NVIDIA's leadership and NetApp's consistent leadership over decades is making it possible for you to accomplish artificial intelligence in a new and meaningful way. We heard a lot also about all these great open source this, open source that. Let me tell you what happened. About 2015, the world really embraced enterprise-grade open source technologies. You heard things from Michael like Jupyter Notebooks and Kubernetes and Kubeflow, and a lot of really great things like TensorFlow, all of which Google created, for the record. So there have been pioneers in the industry like a Google or others who have open sourced their creations to the world. And that's why we have things like Kubernetes now and Kubeflow and the others, as I mentioned. But there's also this big transition going on. How do I adopt the difference between HPC? Do I build it out in a scaled out file system? Do I build a modern masterpiece on NFS with like Apache Spark? Guess what? NetApp today runs one of the largest AI platforms in the world as a Fortune 500 company. And I'm going to show you how we embraced NVIDIA's leadership in software and took the heritage of the open source technologies and made it AI for everyone. NVIDIA also has a great library team. If you would like to take a look, go to agentgc.nvidia.com and you will see pre-packaged, pre-trained models ready to go, depending on what your category is, what you're trying to accomplish, all based upon real deal use cases. The use cases that we see most often in the wild will be anything dealing with cameras. Obviously, that's computer vision for object detection, image classification, image segmentation, advanced video analytics. We have things like natural language processing, natural language understanding, text to speech, speech to text, creating metadata events in documents, or perhaps non-natural language processes, also known as transformers. For example, computer code. For example, chemistry in biotech and science. So there are a lot of amazing things that we can do with software nowadays, and NVIDIA has made it easy for you to do that. So as long as you own an NVIDIA GPU card, you can leverage all the great software that you see at ngc.nvidia.com. And that is the heritage and the basis of what we're doing around our integration story. This is a very simple blueprint. We've worked with customers all around the world. And inside of our $6 billion company, we built a $100 million business overnight. One day I do wish it would be 100 billion. That would be excellent. But how did we do that? We took what NVIDIA did and we took what NetApp did and we brought it together. And so we want to help you work with our top consulting partners all around the world. We've got about a dozen of them that we work with. These are AI consultant partners that do not rinse and repeat, as in they will not take your intellectual property and sell it or show it to someone else. They create data science and use data science to solve business problems. And they're not the traditional consulting partners that you may have heard of that have a portfolio of everything from staff augmentation to networking to you fill in the blank. They just do AI data science work. That's all they do. Companies like SFL Scientific, Data Monsters, Quantify, Quest, to name a few. And essentially, NetApp and NVIDIA, through NVIDIA Professional Services, would like to offer you a use case identification workshop. This is no cost, complimentary to you, and will help you become a fully digital business. We'll help you, again, with your most difficult problems you have. So if you look at your next 18 to 36 months and say, hey, we've got about 2 workloads of AI in production, we've got another dozen that we're looking at in the cloud or wherever, and we'd like to accelerate that process. What do we do next? We want to tackle those most difficult problems. And in addition to that, you heard about one scenario today with Base Command, which is based in Equinix, which I'll talk about in a minute. We also have another way that you can test gear at Equinix or over in NetApp's labs in RTP. We can help you actually do a proof of concept to your business, proving to the business before you make the material impact or the investment. And then the last step is really just building an AI center of excellence. So I want to show you how we do all this. Even though it sounds complex, it's really not. So let me show you. Most customers have a combination of what you see on the screen. And again, with NetApp, we don't care if it's edge, core, or cloud. A lot of customers have most difficulty in the ingest process or the process of doing what we call collecting, correlating, and training of data. So AI training takes a lot of time, a lot of horsepower. It's GPU and CPU computational intensive, depending on how you're accomplishing the workload. But the ability to collect, clean, and correlate on the front end is most difficult in many times. So we want to help you build what we call a unified data lake. Whether you're moving off of things like Hadoop and moving over to Apache Spark, or maybe you're a power company and you've got drones everywhere using computer vision and you want to Look at your plant and say, hey, do I need to cut these plants over these power lines, or whatever sources of data sets that you want to use. Maybe you're a manufacturer and you've got cameras already in place in your factory. Can we leverage all those? The answer is yes, yes, and yes. What you need is an integrated story and a fully blown AI designed data management platform to accomplish that. And I'm going to show you how to do that. So when our customers come to us and they say, Ray, I need your help with AI, we say, what are you trying to accomplish from a business perspective? And we're not necessarily selling them a AI storage or AI data management platform. We're selling them things like this: non-intrusive anomaly detection. This is a real deal POC that we're doing right now with two of the largest companies in the world, a turnkey camera system brought to you by GPU computation, brought to you by NVIDIA's amazing software. And this is what essentially we're looking to use: advanced video analytics. Are there dents in the beer cans? How does the thermal detection system work? Are you also finding, too much water in the beer in the manufacturing process? What does the supply chain optimization look like, depending on how quick the robot/human can load the truck, and then following it throughout its entire life cycle through distribution? So unsupervised anomaly detection from the beginning of origin of creation all the way through supply chain. And then you have things like this, where at the end of our use case identification workshop, we will give you a blueprint and a design that says, do this and you will be successful with your business goals and your tasks. So sometimes it's more difficult to figure out what are the goals, plans, and initiatives that we're looking to accomplish with artificial intelligence than actually accomplishing the execution of that. So loosely translated, yes, there will be plenty of things, the problem we solve for, as I mentioned, whether that's how much water is in the beer, how much dents are in the cans. But a lot of times, artificial intelligence is fundamentally the art of that which is possible that you have not considered yet. And so imagine a day where you could leverage your current camera infrastructure, drop in these pods that we've been talking about today. And I'm going to go deeper into the products in just a minute. But all this is based upon, again, open source technologies, amazing programming software from NVIDIA, such as CUDA, GPU computation at the edge or at the inference here, doing things that traditional CPUs could not do, brought to you by AI storage and AI data management. And that's how we actually accomplish business goals based upon artificial intelligence. Again, this is what you'll get when you leave the use case identification workshop. All this is brought to you by NetApp Storage connected to DGX. As Michael mentioned, DGX is now on its third generation. This is now the DGX A100, and that's featuring second gen AMD EPYC processors. This is an amazing supercomputer in a box. So if you just think about nowadays, I don't know how many cores you have on your CPUs and your servers, but you have 56,000 GPU cores in one DGX A100. Each A100 Ampere card has around 7,000 GPU cores. It's absolutely incredible the amount of transistors and GPU computation dense power that you can get just on one card, let alone a super server like you see on the screen. And this server also comes in many other server formats with NVIDIA cards in them. For example, Lenovo, for example, Cisco, also brought to you by AMD EPYC processors. So I'm going to show you a couple easy ways that you could accomplish this. Yes, you could leverage investment protection, as in you already own NetApp storage, add the NVIDIA DGX A100, and turn your environment into what we call an On Tap AI pod. Yes, you could do that. We've got reference designs to show you how to do that. Or in the inverse, perhaps you've made GPU computation investments in your servers or in DGX, and you want to add NetApp storage, turn your environment into On Tap AI. We can show you how to do that. But what we would recommend is many customers go to the cloud to experiment and fail fast and leverage microservices. That's totally normal. And we're not saying don't go cloud. We're saying do both. And I'll show you how we, NetApp, again, as a Fortune 500 company working with NVIDIA, do both, leveraging both cloud where it makes sense and on-premises infrastructure. But we have a turnkey solution called On Tap AI Integrated Solution, also known as Project Triad for those who have been following it since its inception. This is first call support from NVIDIA. Imagine a day where you have 3 or 4 t-shirt sizes, small, medium, large, and we even have a extra small now, which I'll talk about in a minute. And essentially you have multiple capacity options depending on how much physical storage you actually need, and one support number, one back to pat for everything. You call NVIDIA for networking, for Mellanox support. You call NVIDIA for DGX, data science, NetApp data storage. Again, this is AI storage and AI data management. So this is a solution that is turnkey, ready to go, Traditional triad is built on full HA. I'll show you in a minute. So here's what it looks like. If you need an HA, high availability, mission critical environment that has no single point of failure, we have triad small, medium, and large. And this is based upon 2, 4, or 8 DGX A100 servers, again, featuring second gen AMD EPYC processors. And essentially, we have a non-HA option with a single DGX for maybe some production systems, or maybe you have a smaller data science team of maybe 8 data science, and you want to start out with just one DGX, which again is a highly redundant server internally, but it's just one server. It's a single node, so therefore a single point of failure. So these are, again, the mission critical revenue generating HA options, but we've made this easy for you. You don't need to figure out, hey, how do I connect all this together like Michael talked about? Guess what? It comes ready to go, fully architected, fully designed, management servers, InfiniBand connectivity, Ethernet switches for the NetApp storage arrays, multi-path high availability controllers, everything ready to go to deploy artificial intelligence at production scale. And I say production scale because it's great when you start out with, I have a workload or 2 in production and 7 in the cloud and about 12 on the radar. But what happens over the next 18 to 36 months or even shorter when those workloads move from experimentation to production? There are many infrastructure implications and blind spots that customers don't think about that we have learned, and we want to help you prevent those. And I'm going to cover a couple of those today. Just know that if you wanted to use, according to the design guides, we have NVA 1153 and NVA 1151. We'll provide the links later, but you were more likely going to use a combination of InfiniBand and Ethernet. Although we have a customer in Europe today using 80 DGXs and NetApp storage with all Ethernet connectivity. So if you have a preference to build an Ethernet masterpiece, that's fine. We are going to recommend a combination of both Ethernet and InfiniBand. However, you don't have to if you don't want to. And so you may say, Ray, that sounds great. It's ready to go, but I don't know how that's going to change based upon the performance characteristics, or maybe we're building a massive AI platform to ultimately serve our customers. And when adoption goes up, how do we know which device to add? How do we outgrow it? Are we wasting investments? The answer is no, no, and no. We've got you covered. We've done the testing. We have every use case tested. And I will tell you, if you ever studied the data gravity equation from Digital Realty, loosely translated, your application experience will be most dependent on your low latency. And so we have ultra low latency systems with ultra high throughput. If you said, hey, I'm building an all NFS masterpiece, I need to go 300 gigs a second, and I need to scale it to many, many petabytes in a single solution, no problem. We know which one that we would recommend for you. So we've already done the performance testing from the cost of performance analysis for you to save you time. That gives you more time to value, quicker time to market, less risk, easier time to deploy. And so, again, not just with our consulting partners, but even with our worldwide channel partners, we have a group of people that can really help you long-term do your integration, not just on day 0, but on day 180 or day 360. And NetApp has built a collection of data science tools and MLOps tools to help you with all the great value of NetApp. I mean, there are hundreds of great differentiated NetApp data fabric features. We built an end-to-end data fabric. That way you have access to your data the way you want it, where you want it, how you want it at all times, whether it's in the cloud, on premises, or in a hybrid cloud, near cloud co-location scenario. And again, I don't care if it's edge, core, cloud, or file, block, or object. And on top of that, we built what we call the NetApp AI Control Plane. You heard some terms earlier mentioned, but I'm going to hit them again really quickly. There are essentially machine learning toolkits for Kubernetes. Machine learning toolkits for Kubernetes. And there are some very popular ones out there nowadays. For example, Google's Kubeflow or Red Hat's Apache Airflow. And we have built workflows to help you with orchestration, automation, data engineering, data collection, all at the Kubernetes level. Kubeflow, for example, is going to come with everything you need to start to develop and deploy artificial intelligence at production grade scale, from the Jupyter notebooks to customize for configuration management to the latest version of Kubernetes, and of course, the great Trident plugin that NetApp helped code develop. So having a tight integration story, having super powerful throughput with super low latency on your storage arrays, all those things really matter. And all that infrastructure stuff sounds great, but let's be clear. Maybe you're a data scientist. Maybe you're like, I don't even care about the storage, but I know what you do care about because I talk to data science leaders all around the world, and they do care about getting access to those data sets. In addition to that, they care about getting those amazing models from the code that you wrote in Python in a Jupyter notebook into production. And the big barrier to entry that we see is many times, as Michael mentioned, there's a lot of development that happens in experimentation that never makes it front and center to production. Why is that? Let me tell you why. A couple reasons. Number one, getting access to data sets can be extremely difficult. I talk to some customers, it takes 2 or 3, 4 weeks to get access to all the strategic resources. Copying data, physics comes into play. I don't know if you know, but it takes about 2.74 hours to move a terabyte of data on a 10 gig network. So imagine you're doing that on a 1 gig network, for example, over the WAN. Guess what? 27.4 hours to move a terabyte of data. What happens when you're dealing with massive data in petabyte scale? That's right, you're good at math. It's going to be really slow. So what if NetApp could help you with a data science toolkit? And as a data scientist who, again, doesn't necessarily care about infrastructure or what storage platform is running behind the scenes, what if you could trigger all those great storage and data management features built for AI directly from your Jupyter notebook, your GUI, your experience that you work in every single day without contacting data engineering or IT? That would be a utopia scenario, right? So let me tell you how we do that. We essentially have created the data science toolkit to extend the features of storage and data management all the way up to the Jupyter notebook level. For example, I mentioned how long it takes to copy data. We can give you the ability to copy a 10 terabyte data set, which would take 17 hours on a 10 gig network in 2 seconds time. Now we do that by obviously creating a golden source and only recording your incremental Delta file changes. But that is just one example of over 100 that I could give you that only NetApp can do, that we can extend from the traditional infrastructure level all the way up to people that use complex math to solve business problems known as data science teams. And so these are just a couple examples of the things that we've built to help you out. I also mentioned our world-class channel partners earlier. So if you're a channel partner out there or you work with your strategic channel partner, we have created 18 pages of Ansible Playbooks. You can check out the link here on GitHub to help you manage AI configurations long-term. It's great that if you work with NetApp and NVIDIA and bought Triad, our On Tap AI integrated infrastructure, brought to you by the DGX A100, featuring 2nd gen AMD EPYC processors. But what if you needed to upgrade that to a medium and connect the small to the medium, or there's been a bunch of configuration changes? Well, these Ansible playbooks will help you accelerate your AI deployments, reduce all of your configuration errors, and we literally want to make it complete and simple for you to deploy AI storage at enterprise scale. So I mentioned it earlier, I'm going to wrap this up. AI is born in the cloud. We assume that most customers will go to the cloud first to play around with models, experiments, microservices. But the one thing that you don't think about when you first start doing that is you don't necessarily move all of your data back and forth to the cloud. There's ingress charges, egress charges, and you may rent a GPU, but you're not renting your storage. You pay for whatever you put out there, not to mention who actually owns your data. So what's the balance in between? Well, I'm glad you asked. I showed you the first 2 solutions that we have: NetApp On Tap AI for reference architectures, follow the blueprint, make a beautiful On Tap AI environment, or buy a ready-to-go integrated solution known as On Tap AI Integrated Solution, also known as Project Triad. But Michael mentioned a wonderful new solution called NVIDIA Base Command. This is our second unique and specific differentiator that we only do with NVIDIA. So we have Triad, no one else has that. We have NVIDIA Base Command, specialty platform, and I'm going to show you how that works. NVIDIA Base Command platform is sitting at a co-location facility known as Equinix, which is the core of the known metro edge, or the core of the known internet. Equinix bought all 24 Verizon data centers. They own about 2/3 of the root DNS servers that run the modern internet. They are the core of the internet. And there is a massive environment sitting there that is what I call near cloud that you can use on a monthly basis and have a fully blown, fully managed service, platform as a service, end-to-end turnkey AI infrastructure. The cost actually is very similar to building out an AI center of excellence on premises, as we talked about. And both of these options, Base Command or on premises, will always be more cost effective than cloud. And I adamantly tell you that because we have a TCO calculator that I can show you. I worked with one of our leading software companies in the world recently, and they were taking one model, one algorithm, okay? So algorithmic decision-making is most dependent on how much data you have to level set. And they took this one model, they wanted to train it for high accuracy. It was taking them 3 weeks to train that model in the cloud. That's 504 hours at 7 times 24 times 3 weeks, 504 hours. We ran our TCO calculator, which was just based upon empirical hard costs, not even soft costs, which will add more to the cost inherently. And this was kind of like a cost analysis of cloud versus on premises. And we said, why don't you come to our RTP facility in North Carolina and test the proof of concept, as in do it on the ONTAP AI infrastructure, run the same type of data, which is about 30 terabytes of data. They gave us a copy of their data that they didn't care about getting back or not. We reduced their training time from 3 weeks to 3 hours. We reduced their training time from 3 weeks to 3 hours. We increased their time to develop software in terms of revisions and feature requests and all the great software engineering, 15x. So they were able to deploy software 15 times faster. They were able to do their jobs, 3 weeks down to 3 hours. Absolutely incredible. And then the cost analysis, if those business benefits weren't enough for them, 20 hours of AI training in the cloud was equal to about a $500,000 CapEx purchase. So you can only imagine what the cost analysis showed if you were going to continue to do AI training at production scale for 504 hours. That'd be a lot of money. And so we want to, again, help you do things easier, faster, better, more efficient. And Base Command is one example of doing that, in addition to our great on-premises infrastructure. I mentioned lastly, too, that NetApp had a Fortune 500 AI platform at scale. I want to show you how we do that. We take 300 million IoT telemetry sensor data points from around the world from over 38,000 customers. We put it in Apache Kafka to put it in a structured format. And this is the brain of our artificial intelligence platform at scale. We then put it into Apache Spark 3.0, now GPU accelerated. And we moved off of Hadoop to NFS. I put both of them on the screen so that you could see it. And moving off of Hadoop was amazing. I'm not saying big data is dead. I'm saying that a lot of people are moving off of Hadoop. Hadoop says I must scale servers and storage independently. I must use N+3 or N+5 replication. Lots of cost, lots of time, lots of performance overhead. So using an NFS masterpiece with Apache Spark 3.0 really changed our world. It allowed us to reduce our code footprint from 90% from Java to Python. It allowed us to move to NFS, as I mentioned. And now we take batch into real-time streaming and collect 15 petabytes of data. We keep 10 petabytes on archive and S3 and send 5 petabytes out to the near cloud. Guess what? It lives in Equinix, just like Base Command, at the core of the known internet. And our company told us cloud first mandate. And if you don't go cloud, you better have a business justification for why you're not there. And so we said, what do? We can't legally put our customers' data in the cloud. We're under multiple restrictions for that. So what we did is we ran the brain, as I've showed you here, and we burst into the hyperscale provider, NeoCloud, to run the AI platform at scale, just the API. And essentially, this is what our customers go and download on their smartphone, and it's called ActiveIQ if you want to go check it out. And it's amazing. It allowed us to maintain an element of control, security, intelligence, not having data go back and forth between the hyperscale providers. We even used a technology called Spot to figure out what the most affordable CPU and API instance was at the time between the major 4 hyperscale providers. And this is how we run, as a Fortune 500 company, a 12 production use case AI platform at enterprise scale. So when I tell you the stuff that we talked about today, it is not from a context of theory, but from reality, because we do it ourselves. And so in summary, I mentioned lots of great things. I want you to know that if you want to see an interactive 3D demonstration of everything that we talked about today, we'll provide those links for you. We have the half rack, the full rack of ONTAP AI, the Lenovo equivalent, the FlexPod C480 ML, which is again also based on AMD processors, called FlexPod AI. And when you come in through this interactive 3D tour, it's amazing. You can look at everything that you want. You can take parts away. You can pull things out, whatever it is that you're trying to look into. You essentially just come down and be like, hey, I'd like to take a look at the storage array. How big is that? What's the inside of it look like? What are the features? I mean, it's an amazing 3D interactive demo. So take a look at that. I really appreciate your time today. My name is Ray White. I'm the Artificial Intelligence Leader for NetApp, and we want to help you on your AI journey. Thank you so much for your time.
Awesome. Michael, Ray, thank you both so much for your awesome presentations. We've got just a couple minutes here. I want to try and take a couple of the questions. You guys have been asking great questions in the chat, some very specific, and we're trying to get to those individually. I picked out a few here that are just kind of a little bit higher level. I think we could use to put a bow on the conversation. As I was listening, I heard that there are really two big challenges that I took away here. One is the technical piece, getting it right. There's a bazillion little technical intricacies and nuances that both of your companies have spent lots of time already exploring and getting that right. And then there's the problem of thinking big enough and even knowing what's possible. And I like how you painted a picture for us of some of the things that have been done, but also how you're offering kind of a partnership to help people think through that. You're out there talking to folks every day about what they could do and kind of have that perspective. A lot of times it's hard to see the forest for the trees. And so having a partner to help think big enough, I think, is pretty compelling. Ray, maybe you could take this one. What would you say is the biggest, like, number one barrier to getting an AI project into production for most companies?
That's a great question, James. I would say that it's securing the stakeholders in the business side of the house. A lot of times you'll have a VP of application or someone who has a great idea for a new app to interact with their customers in a different way, for example. It's something they want to automate with advanced software like artificial intelligence. But if the business doesn't understand that the side will increase customer retention, or it will give them cross-selling and upselling capabilities. For example, a different way to talk to their customers about, here's a way to reduce your insurance, for example, but have you thought about, here's a way to prevent having a heart attack? And so when you start to get into those different human elements outside of, again, just cost, that really is what the business side needs to understand, that artificial intelligence will help you save money, reduce costs, and do all those great things, but it will also help you find incremental revenue streams and make a bottom line material impact to your business. So I would say having the business stakeholders would be the most important side that us, the technologists, love to forget about sometimes, James.
Michael, you said 87% of projects never make it to production. I'd be interested in either of your thoughts on, what's the best way to get a project rolling on the right foot to make sure that someday you do get it to production?
Yeah, I couldn't, I totally agree with you, Ray. I think there's so much on the stakeholder and business side that's really critical. I think that in terms of getting a model to production, I think the thing to realize is that it's a journey, right? Like, there's a lot of things that need to happen to deploy that model in production. And typically what I see is a misalignment on, perhaps on the business side or the part of stakeholders in terms of an understanding of what it takes to get that model into production. And then it manifests itself in terms of, a misunderstanding of, like, what types of tools can be used, or what needs to actually be done, like what are the steps that need to be taken. Because I think for many, especially when we see this world of, like, deep learning, it's kind of like looking at an iceberg where we see, data scientists and what they do at that top level, but there's so much more that goes on behind the scenes. And there's so much that goes into building that kind of like an infrastructure that, makes the day-to-day for a data scientist actually possible, right? So I think all of those things are really critical to getting the model into production. And if there's not thought put into, all of those things, that's where I think the, model deployment eventually fails.
Did you want to add anything there, Ray?
No, that was great.
Okay, last question. I think this is all we have time for. If there are folks on the event today who are business leaders seeing the value in AI as you're proposing it, but don't necessarily already have a team of data scientists or even one data scientist who can sort of lead this portion of the project, do you have any advice for them about how to kind of get going?
Yeah, absolutely. I'll take that one. We have a group of AI consultant partners that are absolutely incredible, and they can help you accomplish your goals, plans, and initiatives based upon artificial intelligence. I would recommend you reach out to NetApp and NVIDIA. Can offer you a use case identification workshop. And long-term, something like NVIDIA NetApp Base Command Platform could be that solution for them. That way they have everything they need from platform management, data science support, infrastructure support. It's ready to go. It's secure. It's safe. Again, it's the data is at the core of the known internet. So I think that is a great fit after a workshop for NVIDIA Base Command Platform.
Great. Well, again, Michael, Ray, thank you so much for presenting for us today. To all of our attendees who are on the event today, just a reminder, make sure and grab the handouts. We're so thankful that you came. And one last thing, I've got a gift card to give away. That gift card is going to go to Wes Nichols from Mississippi. Wes Nichols from Mississippi. Congratulations, you're the winner of the $300 Amazon gift card. We'll be reaching out to you to get that delivered. To everybody else, again, thank you so much for being here. It was great to have you. Sorry we went 3 minutes over, but I appreciate you hanging in there. Have a fantastic day. Don't forget to grab some handouts on your way out and check out events.actualtechmedia.com to see what else is coming up that might be of interest to you. Have a good one, everybody.